Hello, this is Real World Audio, and we are continuing exploring what the voltages do to the sound. So at the first part of this video, we have explored what is the difference between a Darling amp and the 200 watt solid state amplifier as far as their dynamic resolution goes. So we explored what is the dynamic peak and what is the dynamic low, and if you are listening at average or whisper volume, what is the capability that you can get out of each of them using either high efficient, ultra efficient, or low efficiency loudspeakers. So right now, let's have a look at what happens when we go close to the noise floor. So what are the typical noise floor levels? So if you take an average amplifier, then approximately 1 millivolt is the level of the rail hum. There are solid state amps which have much lower, but others which have higher, quite a bit higher than that. So I'm taking that as an example for today. And for the Darlings, these two versions, the Baby Darling will have about 2 millivolt of rail hum, and the Pure Darling has 0.2 millivolt of rail hum. However, I have to add something for you guys, that this is not the outgoing hum level, because the output transformer is going after these. So you really have to divide that value based on the output tap of your transformer. So you can divide this figure by 20 to get the hum level of your amplifier. So it's like at least 0.1 millivolt or 0.01 millivolt hum compared to the 1 millivolt hum that goes out. But this is, I'm showing the real voltages because that is the capacity of the last gain stage to create dynamic resolution. So when we are looking at a whisper level reproduction using the ultra efficient loudspeaker, we have 25 millivolt available. So it means that in the case of a Baby Darling, we have over 10 times headroom for signal versus hum, and 10 times in voltage. And for our solid state amp, we require 0.4 millivolts and the hum is 1, so we are 2.5 times under the hum level. So whatever we are hearing or we want to hear, it is going to be totally masked by the hum of the amplifier. And if you look at the Baby Darling, the Pure Darling, excuse me, if you look at the Pure Darling, then the hum level is 10 times less, so we have over 100 times headroom in the voltage level, voltage domain for between the whisper level reproduction and the noise floor of the amplifier. So what does that mean? So this means that in the case of the Darling amps, we have even at whisper level tremendous dynamic resolution, but then we are way beyond resolution in the case of the solid state amp. Of course, you would be saying that most of us are not running 200 watt amps with ultra efficient speakers. Yes, that's true. With those speakers you are running it, there you will have headroom, and you will be able to hear, but only if you go for really inefficient loudspeakers. If you have 83 dB loudspeakers, then you will have a safety margin. But if you go for even like a good efficiency, like 95 dB, then you are already below the noise floor. So all your low level detail information is going to get erased. Yet there is another thing, is that sound floor is not equivalent to noise floor. So In the case of a solid state amplifier where something comes close to the noise floor, it will be a hard block, because solid state amp noise floors are really nasty. It's a nasty hash which destroys every information which is below the noise floor. And I would say not just below the noise floor, but anything that even comes close to the noise floor, it's going to get erased. In the case of tube amplifiers without feedback, especially, the noise floor is almost a pure sine wave, and it's a single frequency. Usually it's defined by your, well, not usually, always defined by the frequency of your power supply, of which depends on your line voltage. So we are talking about 50, 60, 100 or 120 hertz. So at these frequencies you have a hum, a low level hum. However, if your music signal is going close to the hum level, the ear can still pick the two apart. So for example, try out this experiment. Try to listen to a 120 hertz sine wave at pretty loud level. If you are talking even quiet next to that loud 120 hertz noise, you can still hear each other and have a perfect conversation. Same thing is happening with a tube amplifier, that there is a hum, but you can get the dynamic resolution under the level of the hum, so we can hear, and that gives us quite a dynamic range below the hum floor. Of course, the hum is going to destroy the same frequency information where the hum is happening, but so it will be a distraction, but it will not be an elimination. So it will still allow you and allow your brain to process the music, what's going on 10 or even 20 dB below the hum level. And in the case of a solid state amplifier, even if you are going close to, like within 15, 20 dB of the noise floor, the low level information which encodes the timing, the spatial information, all that information which makes the difference between recording and live sound is going to get erased. So we have like a tremendous difference. Like this gives us at least 30, 40 dB advantage for tube amplifiers at the whisper level compared to a solid state amplifier. So do I have additional slide? So basically, when you have a tube amp such as the Darling amplifier, there is no hard floor for the low level information. It can reach quite a bit below the noise floor of your amplifier. So that's why the sound floor is much lower than the noise floor. So the sound floor is something that Arthur Salvatore started to use that expression, which means that the lowest level sounds that you can hear from the system, and that's not defined by the noise level. And this is true for both tube amplifiers, and not just tube amplifiers, but analog recordings as well. So when you hear that LP, vinyl and cassette tape has a certain dynamic level, it doesn't mean that that's it and nothing else, but you can hear quite a bit below the noise floor for both of these media, especially when you listen to vinyl and you hear like pops and clicks and a hiss or anything, you can notice that you can hear quite a bit below that noise level. And when you have digital, there you have a hard floor. And even if you go like 30 dB close to 0 dB level, you are already losing tremendous amount of information. So digital is king when it's high level signals, but when you drop to whisper level, then the resolution fades away, both texturally and both dynamically. So I think, let's see. So we will continue noise floor versus sound floor, and for that one I will draw and I will showcase my abysmal drawing skills, because that's going to really show you how what is the difference between noise floor and sound floor, and why is it that the tube amps, they can dig quite below their hum level, and why solid state amplifiers have issues even just going near that range and not below that. So thank you for tuning in. Like, subscribe. Bye bye. Thank you.